everyone, and welcome to Precalculus, section 3.3, Properties of Logarithms. This is usually everybody's favorite section in this chapter. The first little thing I want to just get out of the way is something called a change of base formula. Most of you have a newer calculator, and you have a button that specifically does log base A, meaning you could do log base 10 or 3 or 12. But older calculators don't have that functionality, and they only have log base 10, which is what this is. Remember, if there's nothing there, then we assume it to be log 10. So a little workaround for this on an older calculator would be if you need to do log base 4 of 25, for example, you could just do log of 25 divided by log of 4. And honestly, I actually still do it this way. Partly because I'm from the older calculator generation, but also because it's less keystrokes than finding this button on the calculator, which is inside of a menu. So log of 25 over log of 4, and that gives you 2.3219. It also works for natural log. So if I changed this to natural log of 12 over natural log of 2, that also will work. And that gives you 3.5850. So real quick, if you're in honors especially and you're like, but why? Why does that work? So let's just say you had log base 3 of 6 is equal to x. And I exponentiated both sides, meaning I made it log to the log base 3 of 6 is equal to 3 to the x. Think about that. If you have 3 to the x is equal to 3 to the y, then x must be equal to y. So since these two things are equal, I can make them both a power of 3. But then on this side, that simplifies. Do you remember that from last class? If you have a base 3 and a base 3, it cancels. So I get 6 is equal to 3 to the x. And then I'm going to do a weird thing. I'm going to take the log base 10 of both sides, log base 10 of 3 to the x. And then there's a little rule we're actually going to learn today that says you can move the x out into the front. I'll teach you why that works today. And therefore, x is dividing both sides, log base 6 over log base 3. So that's a little why behind why it works. All you need to know is really that it does. So the reason I still teach it, even if your calculator is capable of doing it, is because this is how your book will express the answers in section 3.4. And I don't want you to be wondering what they're doing. All right, so let's move on to the bulk of the section, which is properties of logarithms. Here's the one that I just used a minute ago. When you have a power, you can actually bring it out in front, which I know is totally bizarre. Hopefully you learned these in Algebra 2 and they're not completely unfamiliar. But real quickly, if you have log base anything, let's just say base 3 of x times y, you can separate that into addition problem. Log base 3 of x plus log base 3 of y. That's an example of that one. But if you had log base 8 of x over y, it becomes a subtraction problem. And for those of you that are thinking, well, I'm just going to memorize it, 8, but I have no idea why it works, I do want to make you understand, if I can, which is, think about properties of exponents. X squared times x to the third. This is something you understand. This is x times x times x times x times x. And we call that x to the fifth. But nobody does that. Instead, you just say, oh, when you're multiplying like bases, you add their exponents. Done. But over time, you might have forgotten why you add the exponents. It's because it's x times x times x times x times x is equal to x to the fifth. Well, remember that exponents are the inverses of logarithms. So their inverse properties apply. Just like here, multiplication of the bases meant you added the exponents. Multiplication of your x and your y can be changed to addition with logarithms. So hopefully that gave you at least a sense of why it works. And this little rule that I introduced a few minutes ago says that if you have log, we'll just keep it base 10 to keep it simple, of, let's say, 3 squared, I'm telling you that you can put that 2 out in front. And here's the why. Because I can switch that to log of 3 times 3, and then using my rule up there, I can change that to log of 3 plus log of 3. And what do I have? I have 2 log of 3. Right? So that's why that one works. So these are the 3 properties that we're learn today, and we're just going to spend the whole block using them and making sure that you get them by the end. So when you had this problem very similar the other night, you might have switched it to log base 5, 5 to the 1/3. And then you canceled this because it had a base 5 and the exponent had a base 5, and you just said that's 1/3. Now sometimes kids say, oh, but do we have to move the 1/3 out in the front? Sure. All the properties still work, even the ones that you learned last class, nothing's new. Because this becomes 1, and 1 times 1/3 is 1/3. So it still works. Similarly, on this one, you might have looked at it and said, oh, natural log and e cancel each other out. Natural log and e cancel each other out. You get 4. Where somebody else says, I see subtraction. I'm going to put them together as division. Great, they can do that. Natural log of e to the 4th. And then the natural log and the e cancel, and you just get 4. So either way, you're going to get 4. So what's going to happen is you're going to have some choices on how you do these problems. Don't let that throw you. Okay, so this skill is not going to seem very important right now, but it is absolutely essential in calculus. And that is taking a logarithm that's hard and making it into something easy. And that's called expanding. So by my rule, if these are being multiplied, I can switch them to addition. Don't forget to write the base 4 each time. It's an easy thing to forget. And it's not considered completely done until there's no exponents either. So this is going to be log base 4 of 5 plus 3, that's going to come down in the front, log base 4 of x plus log base 4 of y. That's called expanding. On the next one, I have 2 things that are being divided, so I can switch them to subtraction. I'm also going to get rid of my square roots. You don't want any square roots, so instead I'm going to change it to the 1/2 power. And then, like I said, your second step is always going to be to get rid of any powers. So I bring that 1/2 down into the front. Notice that it is only affecting the natural log of 3x minus 5. It does not affect the natural log of 7 because the square root was only on the 3x minus 5. So there's basically 2 steps in expanding. One is separating it into addition if it was being multiplied, or subtraction if it was being divided. And then the second step is getting rid of any exponents by bringing them to the front. Conversely, we have something called condensing. And now the order is going to be backwards. Now your first step is going to be to recreate the exponent, which last time we dealt with the exponent as the second step, but when we're condensing, we're going to make that the first step. And then the second step, we'll be putting it back together as a single logarithm. So log of, and you can call this square root, or you could have left it x to the 1/2, either way, to the 3rd. So we have 2 more condensings here. So remember that your step 1 is going to be to move your exponents. And then your step 2 is going to be create a single logarithm. So my first step, I'm going to make this natural log of x plus 2, the quantity squared. I took care of my exponents. And then my second step is to create a single logarithm. So natural log of these two things. But since it's subtraction, I'm going to put that on top over x. Or you could just, if you can write neatly, you don't really need those brackets there. It's pretty obvious. But it is not. I will tell you what the number one biggest mistake in this section is. It's changing it to division, but still keeping two natural logs. Very, very, very common mistake. Watch out. I don't give any partial credit for this mistake. You are condensing it to a single logarithm. Two logs being subtracted is not the same as two logs being divided. It's the same as a single log being divided. Number 7. So this 1/3 needs to be distributed. So we don't have that on our list of steps. It doesn't always appear, but I would do that first. And now it looks like one of our other problems. My second step is to move the exponents. So log base 2 of x to the 1/3. You can change it to cube root if you would like. So I'm going to do that on this one so that you see that you have choices. Either notation is fine with me. Then I'm going to join them as a single log. So it's going to be log of this entire thing, x to the 1/3 times the cube root of x plus 1. Now, honestly, this would be a little silly, one being in a fractional exponent and one not. So I'm going to write it as a single one, and I'm going to put them both underneath there, x times x plus 1. This is fine, but I do have kids that are going to write it as x squared plus x. That's also good. Or you really might like fractional exponents. X squared plus x to the 1/3. Also fine, okay? So you definitely have some choices. When you have numbers, sometimes people feel that they're just a little bit trickier, but just treat them the same. Natural log of 6 minus natural log of e squared. Now you do have to remember your properties. Natural log and e cancel each other out. So this becomes natural log of 6 minus 2. But be careful. This is not the natural log of 4 because it's not the natural log of 6 minus 2. That minus 2 came from something else. So you may want to rewrite it as -2 plus the natural log of 6. Not required unless you're accidentally going to write 4, which you really don't want to do. So you're always going to want to change your roots to fractional exponents. Hopefully you remember from last time that the 6, base 6, and then the base 6 here cancel each other out, and you can just write 1/3. So you're getting to repeat these problems that you had in the last section, and I think the book is doing that because they're thinking some people might move that 1/3 to the front, but you really can just do it right away. A lot of people struggle with number 3 because they do cancel the natural log in the e and leave it with 4, but sometimes they write 3 to the 4 as if the 4 is still raised. But the natural log of e to the 4th, these two operations cancel each other out, and so 4 is back, I'm going to say on plane. Like if you're writing on a line, it's not an exponent anymore. It's back where it belongs. So be really careful. This is going to be 3, and then this piece right here simplifies to 4. So it's just 3 times 4, which is equal to 12. I see another fractional exponent. So now that there's an exponent and the fractional exponent, you're going to make it 3/4. The numerator is always the power that's actually associated with it, And then any kind of root becomes a denominator in the power. Again, natural log and e cancel each other out, and the answer is just 3/4. So people are going to do this different ways. You might look at this and say, oh, natural log and e cancel each other out. This is just 12. Natural log and e cancel each other out. This is 5. And 12 minus 5 is 7. That's good. Or sometimes people make it a lot harder than it is. They do raise the 2, but now they have e to the 6th squared. And if you're going to write 8, you'd be wrong. It's going to be natural log of 12, or e to the 12. So you multiply when you have power to a power, minus natural log of e to the 5. You can put those together now since it's subtraction. E to the 5th, which gives you natural log of e to the, remember your rules of exponents. Division correlates with subtraction. And then this, of course, is just 7. So this was longer, but you at least have choices. So whatever makes the most sense in your head. But these you learned last section, and you're still welcome to use those rules. There's nothing to say you have to do this long, convoluted method. Okay, last one's a little bit tricky. So they are both base 4, so you can put them together and you can multiply them. 2 times 32, because they were addition, now you can multiply them. That would give you log base 4 of 64. Now, if you stopped here, it would be like if I said to you, can you reduce 50 over 100? And you said, oh yeah, I can cancel the zeros. That's 5 over 10. You did a good job, but you didn't simplify it all the way. You didn't reduce it all the way down to 1/2. Similarly, this can be simplified because you're not always going to see this. 64 is a power of 4. It's 4 to the 3rd. So this actually just becomes 3. And that's a little hard to see. But if you think about it, when you were first learning fractions, just seeing this was a little hard to see. So everything just takes practice. All right, so these next few examples are all expanding. Don't worry about the x is greater than 1. That's there because you can't take the log of a negative number. So it's my responsibility to write it, but it doesn't really affect your doing the problem at all. So there's 5 more expanding, and then there's 5 more condensing. If you would like to try those on your own, that's what I would have you do if you were actually in the classroom. But you're not, so I am going to do them for you. But the more you do on your own, the better. This is multiplication, which in logs translates to addition. So log base 3 of 10 plus log base 3 of z. On the next one, I have division, which I can change to subtraction. Natural log of x squared minus 1, don't forget your parentheses, minus natural log of x cubed. You can't leave the 3. You would only get partial credit for this problem because you can bring the 3 down. Now you might be wondering, well, can I move that square? You cannot. The x squared minus 1 are attached to each other, so you cannot. If you stopped here, you would only lose 1 point if you were in college prep, because this next step is a little bit tricky. But if you're in honors, I need to see that you can do this next step. X squared minus 1 is factorable. Very, very hard to see. Just to think of. Once I show it to you, you're like, oh yeah, of course. And now you have a multiplication problem. And now you can make it into addition. A little bit tricky, that one. Number 9, my personal first step is always to change this to a fractional exponent. So this is x squared, and now it's to the 1/2. And in the denominator, it's y cubed to the 1/2, which when you're putting those together is going to be just x to the first over y to the 3/2. Now you didn't have to show this middle step. Like I said, it's very easy to do. A square root becomes a 1/2. So the 2 gets to go on the top, and the 1/2 that 2 goes in the denominator. So you could probably jump to that step, but I'm trying to show as many steps as possible, at least on the videos, because you're not here to ask me a question. So then from here, because it's division, I can change it to subtraction. And as a final step, you're not allowed to leave any exponents in your answer, so the 3/2 would come out into the front. Next one. Natural log of the square root of x, y to the 4th. So the very first thing I'm going to do is rewrite it with x to the 1/2. And it's over z to the 4th. All right, so this is the first one we've had where we have 3 things going on. There's an x, a y, and a z, but all the same rules apply. If it's being multiplied, you can change it to addition. If it is being divided, you can change it to subtraction. Don't forget there's a little base 2 on all of them. And as your final step, you're always going to bring those exponents down. That's expanding. And being good at this will help you a lot in calculus. I have a fractional exponent, a square root that I'm going to change to a fractional exponent again. So this is x squared times x plus 2 to the 1/2. Well, that 1/2 can be distributed. This is always confusing for kids. If you have xy squared, you can distribute it because xy times xy is x times x, which is x squared, and y times y, which is y squared. So in this case, you're allowed to distribute. Where people go wrong is they have this, and they write x squared plus y squared. This is a big no. But the reason is because unlike this one, that when you actually did the multiplication out, it worked. This one, if you actually do the multiplication out, you're going to get x squared plus xy plus xy plus y squared, which is not equal to x squared plus y squared. So you can distribute if things are being multiplied. You can distribute an exponent. You cannot distribute an exponent if they're being squared. So keep those 2 things in mind. So on our problem, that 1/2 with the 2 just makes that an x. And this 1/2 with the x plus 2, I'm just going to put with that one. And I can separate them. So natural log of x plus natural log of x plus 2 to the 1/2. Your final step is always to make sure you have no exponents. So I'm going to bring the 1/2 down to the front. There we go. Let's do some condensing. Remember, you want it to be a single logarithm in the end. So even though this is multiplication, don't write natural log of y times natural log of t. Okay? Make sure you write as a single logarithm, natural log of yt. You can have parentheses or not, it doesn't really matter. So when you're doing condensing, you want to take care of the exponents first. And I don't mind if you do this. I'm moving the 3. I'm moving the 4. Now here's an interesting dilemma. I'm just going to move the 4. I'm going to do it 2 different ways. If I do that, I have addition. So I'm going to write my single logarithm. These are being added, so they go on top. This is being subtracted, so that goes on bottom. Now another way to do it, let me just rewrite it first. Log base 3 of x plus 4 log base 3 of y minus 4 log base 3 of z. So this person, they move it, but they also move the negative 4. And now it's addition. If you move the negative, that whole -4 to the exponent, you can do that. But now this will be addition because you took the negative away. So now you would have log base 3 of x cubed times y to the 4th times z to the -4. But these two answers are the same. I would say every book is going to write it this way, but it is the same to have z to the -4th because that means z on the bottom. Remember that when you have some extra parentheses in there, it just makes things confusing. So I would distribute it. And sometimes you can do steps here that you aren't doing there yet. So if on this step, I move that square, you can see I'm not the kind of person that moves the negative. I leave the negative and just move the number. You can move that, even though I didn't move these yet. And then everybody's trying to save themselves some time, so you can just go like that. With condensing, you want to change it to a single logarithm. Things that are being multiplied can change to things that are being added can change to multiplication, and things that are being subtracted change to division. Next one, my first step would be to distribute that 2. So I have 6 ln of x minus 2 ln of x plus 1 minus 2 ln of x minus 1. Okay, so this one's a little bit hard for people because, oh, not yet. Let's move the 6. Let's move the 2. Let's move the 2. It's hard because I have 2 divisions. So sometimes people do this over x plus 1 squared, and then they're like, oh, I have to divide again. You do not want to do that. Think about it. When you had 2 things being multiplied and 1 thing being divided, you just put the 2 multiplied things on top and the 1 divided thing on the bottom. Now you have 1 thing being added, so you're going to write natural log of the x to the 6 goes on the top because it's positive, and the 2 negative ones are going to go on the bottom. Now, this is a perfectly good answer. You could box this and you could stop. But if you looked in the back of the book and that answer wasn't there, you might be confused as to why. So I will show you that it's possible that somebody else would think, well, but this is just easy to simplify. X plus 1 times x minus 1 is x squared minus 1, which is true. So you have x plus 1 and x minus 1 twice. Line is no good on this. So you have it here and here. So somebody might say, I'm going to write this as x to the 6 over x squared minus 1 squared. That's probably how you would see an answer instead of something like this, because these two multiply together so nicely. Does that mean I'm not going to take this? No, good job. It's already a hard problem. Next one, I'm going to distribute my 1/2 first. You always want to get rid of those extra parentheses. They just cause trouble. 1/2 times 2 is 1, so that goes away. And then I have 6 log base 4 of x at the end. I'm going to move all my exponents. So this 1/2 I'm going to put there, and this 6 I'm going to put there. Now I have log base 4, and everything's being added. So this is the square root of x plus 1. This is just x minus 1. And this is x to the 6. There is no better way to write that. However, most people will put a monomial first and a square root at the end. But I'm just going to write or. I'll take either answer. They're both fine. Sometimes kids will just put brackets around the whole thing. That's fine too. Lots of possibilities for your answers here. All right, so that's it for expanding and condensing. Like I said, once people get it, it's usually the favorite section in chapter 3. Have a great day.